You have driven past thousands of them in your life, and you have never noticed the geometry. A stop sign. Bright red white block letters spelling stop, and a perfectly octagonal silhouette. 8 sides. Not 4, not 6, not round. The shape is so universal, you have probably never questioned it. Most drivers assume the 8 sides are arbitrary, or aesthetic, or just when someone in a traffic department decided one day. But the octagon is none of those things. It is the result of a 1923 Detroit traffic engineering problem about what a stop sign should look like in a snowstorm from the back, with the letters completely hidden. Here on the reason why. Drive through any city, suburb, or rural town in any country and pass a stop sign. The shape is identical everywhere. 8 sides, red background, white block letters. The letters are reflective. The post is metal, and the bolts are weatherproof. The sign sits at the corner of every intersection where a driver might be tempted to roll through without slowing down. You have looked at thousands of them in your life. You have probably never noticed the corners, but the corners are not arbitrary. The 8 sides are doing real engineering work, and the work happens in conditions where the sign is functionally invisible. The story starts in the early 1900s. American cities were drowning in cars. Roads built for horses suddenly had Model Ts crashing into each other at intersections. Traffic engineers needed a way to tell drivers when to stop, and they tried everything. Round signs that meant slow down, diamond-shaped warning signs, square regulatory signs, triangular yield signs. By 1915, every American city had its own set of shapes, and a driver crossing state lines might encounter 5 different shapes that all meant the same thing. The system was chaos. A National Association of Traffic Engineers met in 1923 to standardize the country's signage. The first question was the most important. What shape should the stop sign be? The Detroit Committee proposed a hierarchy of danger by number of sides. The more sides a sign had, the more dangerous the situation it warned of. A round sign meant warning, slow down. A diamond meant general caution. A rectangle meant regulation, like a speed limit. The shape of greatest danger needed the most sides, signaling immediate stop. The committee argued. They proposed circles, hexagons, octagons, 12-sided figures. The hexagon and the octagon both seemed plausible. They needed a tiebreaker. So they tested the candidates in the only condition that mattered for safety, when the sign was completely unreadable. Snowstorms, fog, vandalism, viewed from the back of the sign. And here is where the engineering got brilliant. The Detroit team imagined a driver approaching a 4-way intersection in a Michigan snowstorm. The stop sign on the cross street is half buried by snow on the post. The reflective letters are coated with ice. From the back, the sign is just a silhouette. The cross-car driver needs to know if the perpendicular driver has a stop sign or not. With a circle from the back, the driver cannot tell. Circles have no facing. With a hexagon, 6 sides looks like a regulatory sign. With an octagon, the silhouette is unmistakable. 8 sides means stop from the back, in a snowstorm, in any direction. The shape itself does the signaling. But here's the question the Detroit team also had to answer. Why 8 specifically? Why not 9 sides? Or 10? Or 12? The answer is manufacturing geometry. An octagon can be cut from a square sheet of steel with 2 simple diagonal cuts on each corner. 4 cuts total. No curves, no precision tooling. A hexagon requires a regular hexagon stencil and 3 cuts at 30-degree angles. A 9-sided shape requires odd angles. A 12-sided shape costs more steel. The octagon was the only shape that combined unmistakable visibility, hierarchy ranking, and cheap manufacturing in one geometry. Every other candidate failed at least one test. The 1923 Detroit decision was published as the American Manual on Uniform Traffic Control Devices In 1935, American highway engineers spread the spec across the country in the post-war interstate boom. Then, American military engineers stationed overseas after World War II brought the octagonal stop sign to occupied Europe and Japan. Then the Vienna Convention on Road Signs in 1968 codified the octagon as the global standard. Today, every country that uses the Latin alphabet stop sign uses the octagon. The shape on every street corner from Toronto to Tokyo to Mumbai is a 1923 Detroit traffic engineering decision about how a sign behaves when nobody can read the letters. So the next time you slow down at a stop sign and your eye registers the 8-sided silhouette before you even read the letters, remember, that is the entire point. The octagon was designed to be recognizable when the letters are invisible. From the back, in a snowstorm, with the paint faded, with the reflective coating worn through, the 8 sides still mean stop. The shape is the message. The letters are just the confirmation. A 1923 Detroit traffic committee solved an unreadable sign problem with a geometry trick that has guided every driver in every country for 100 years. The octagon is one of the quietest pieces of safety engineering you have ever driven past without noticing. Look at the silhouette of the next stop sign you drive past. The 8 sides are not a stylistic choice and not an aesthetic decision. They are the result of a 1923 Detroit traffic engineering committee that imagined a driver approaching an intersection in a Michigan snowstorm and asked one question. If the letters are invisible, and the post is half buried in snow, can the silhouette of the sign alone communicate stop? The committee considered every shape from a circle to a 12-sided figure. The circle gave no directional information. The hexagon was confusable with a regulatory sign. The 12-sided figure cost more steel and was harder to manufacture from a flat square sheet. The octagon was the only shape that hit every constraint at once. The 1923 decision was published in 1935, spread across America in the post-war highway boom, exported to Europe by occupying military engineers after World War II, and codified globally by the Vienna Convention in 1968. Every red octagon you have ever stopped at in any country is the same 8-sided answer to the same Michigan snowstorm question. The shape is doing the signaling work that the letters cannot. You have stopped seeing the octagon because it works. The silhouette has been doing its job since the year your great-grandparents first started driving, and it will be doing the same job 100 years from now. On a planet where the cars are very different, but the storms still happen, and the silhouettes still need to be readable. If this kind of small engineering decision, quietly shaping your daily life story, is your speed, there is a whole channel of stories like it. The reasons behind everyday objects you have stopped questioning. Subscribe so the next one finds you and quietly lands in your feed without you having to look for it once.